over trig substitution real quick. And before we get started on the problem, the example problem, you should know that whenever you're integrating and you have all these different types of integration techniques, you know to use trig substitution whenever you see any of these three types of forms. And the three types are x squared minus a squared, and a squared minus x squared, and x squared plus a squared. So when you have x squared minus a squared in the problem, you should set your x equal to a secant of theta, and the dx equal to a secant of theta tan of theta d theta. If you have a squared minus x squared, you should set your x equal to a sine of theta, your dx equal to a cosine of theta d theta. And if you have x squared plus a squared, you should set your x equal to a tan of theta, and your dx equal to a secant of theta d theta. Alright, now that we've gone over that, close up here. Now that we've gone over those, we can get started on the example problem. And the problem is integrate dx over x squared times the square root of x squared minus 4. So when you're doing this, you automatically can recognize that you have the x squared minus 4, which is the same form as x squared minus a squared, your a being 2. So since we just went over that, we know that if we have x squared minus a squared, we set our x equal to a secant of theta. So we start here, we'll say x equals a, and our a is going to be 2. So 2 secant of theta. And our dx will therefore be equal to 2 secant of theta tan. Our dx is therefore equal to 2 secant of theta tan of theta. So after we do this step, we can go ahead and start plugging in everywhere we see an x, go ahead and plug in 2 secant of theta. So we'll go ahead and rewrite the problem here. And everywhere we see a dx, we go ahead and plug in 2 secant of theta tan of theta. So I'll go ahead and rewrite it as So the problem now is the integral of 1 over 2 secant of theta squared times the square root of 2 secant of theta squared minus 4, all times the quantity of 2 secant of theta times tan of theta. So after we do that step, we have to simplify the problem down. And so the first simplification step that we can do is go ahead and square these two out. So that's what we're going to do next. We went ahead and squared them out, and now we have the integral of 1 over 4 secant squared of theta times the square root of 4 secant squared of theta minus 4 times the quantity of 2 secant of theta tan of theta d theta. So what we're going to do next is we see that the 4 secant squared of theta minus 4 both have a 4 in common on both sides, so we can go ahead and pull the 4 out, like factor it out. So we'll do that next, and we'll get so now we have the integral of 1 over 4 secant squared theta times the derivative of 4 times the quantity of secant squared theta minus 1, all times the quantity of 2 secant theta tan of theta d theta. And if you remember your trig identities, then you know that secant squared of theta minus 1 is also equal to tangent of tangent squared theta. So we can go ahead and change that to tangent squared theta. And while we're at it, I'll go ahead and move the 2 secant theta tan theta to the top here to make it easier to write. So now what we have is the integral of 2 secant theta times tan theta over 4 secant squared theta times the square root of 4 tangent squared theta d theta. So we can go ahead and take the square root of this, and if we take the square root, that's just going to equal 2 tangent of theta, and since you're taking the square root of 4, which is 2, and the square root of tangent squared theta, which is just going to be tangent theta. And after you get that, you can go ahead and simplify it and multiply these together, and what you're going to get is this. So you're going to get this. This is the integral of 2 secant theta tan theta over 8 times the secant squared theta tan theta d theta. And basically from here, you can go ahead and cancel out your 2 tangents on top and bottom will cancel out. The 2 and 8 will turn into a 1/4, and the secant squared theta and on the bottom and the secant theta on the top will just cancel out to 1 over secant theta. And I'm going to go ahead and write that up here. So this is the problem now, this integral of 1 over 4 secant theta d theta. You can bring the 1 over 4 outside of the integral since it is a constant, and you'll just have a 1 over secant theta d theta. And 1 over secant theta is the same thing as cosine of theta. So we can go ahead and change the problem now to the integral of 1 over 4 cosine, or the 1 over 4 times the integral of cosine theta d theta. So as I said before, we took the integral of 1 over 4 secant theta d theta. We brought the 1 over 4 out. because it's a constant, we can do that. So, and then the 1 over secant theta is this equal to cosine of theta, because they're the same thing. So now we have 1 over 4 times the integral of cosine of theta. And we know the integral of cosine of theta, it's sine of theta. So the answer to this is going to be 1 over 4 sine of theta. Now, we're almost done with the problem. All we have to do now is figure out what theta equals, because we can't just leave it in terms of theta since we don't know what theta equals. And to do that, we'll have to go back to what we did in the beginning. And I'm going to go ahead, So we went back here, and where we said x equals 2 secant of theta, we can go ahead and write that down here. And we can go ahead and solve this algebraically to make it x over 2 equals secant of theta. And we know secant of theta is also equal to 1 over the cosine of theta. So we can go ahead and change that to x over 2 equals the 1 over cosine of theta. Just get a closer look at it. So we went back to the beginning and we said where we said x equals 2 secant of theta. And we started solving it algebraically. We divided the 2 over to make it x over 2 equals secant of theta. And we know secant of theta is equal to 1 over cosine of theta. So now we have x over 2 equals 1 over cosine of theta. We can go ahead and draw a triangle to figure out what the angle theta is. We can draw theta right here. And if you remember, some geometry, you'll remember that SOHCAHTOA, or helps you remember, what sine and cosine and tangent equal. And so we know that cosine is equal to adjacent. Is equal to adjacent over hypotenuse. But since we have 1 over cosine, it's going to be the opposite. So now, instead of having x over 2, since this is adjacent, that's hypotenuse, you're going to have x on the hypotenuse and 2 on the adjacent, because it's 1 over cosine. And using Pythagorean theorem, we can figure out what this leg is. And you know that a squared plus b squared equals c squared. So if you have this, you have 2 squared plus something equals x. So you know that the 2 squared is going to equal 4. And you want to be able to cancel the 4's out. So it's going to be the square root of x squared minus 4. Because if you square this, if you square the 2 there, if you square the 2, and you'll get 4, and if you square this, you'll get x squared minus 4. So the 4's will cancel out, and I'll leave it with just x squared, and it's supposed to equal c squared. So if you take the square root of x squared, you get x, which is c. So you know that is x squared, the square root of x squared minus 4. And so now that you know that, you can go back up here to where you had 1/4 sine of theta. Using SOHCAHTOA, you know sine equals opposite over hypotenuse, and your answer will end up being